So I have this triangle XYZ, and I've labeled X as 35 degrees. I labeled little x as 5 centimeters, little y as 3 centimeters. And I didn't have this, I found this afterwards. But let's see how I found this. Again, I'm going to set up the sine law because this is a non-90 degree triangle where I have two side lengths and an angle opposite one of the side lengths. So I can label this as sine x over little x and sine y over little y. So that's what I did here. Sine y over little y is equal to sine x over little x. And I filled in the blanks. Little y is 3. Big X is 35. Little x is 5. I didn't know what y was. So I wrote sine y is equal to, cross multiply the 3. So I got 3 sine of 35 over 5. Now I figured out what 3 sine 35 over 5 was. And when I got that, I got 0.3441456. So sine of y is equal to this positive number. Again, if you have sine y is equal to a positive number from our last section, I know sine is positive in quadrant 1 and in quadrant 2. In quadrant 1, I will get an acute angle. In quadrant 2, I will get an obtuse angle. Acute angle between 0 and 90. Obtuse angle being between 90 and 180. So I go to solve this regularly like last year, bring sine to the other side, sine inverse of this answer, and I get y is equal to 20.1. And of course I can write 20.1 there. That is my first answer. It's my acute answer. My second answer though is obviously figuring out what that angle is in quadrant 2. And I do 180 minus 20.1, and I get 159.9. Now, if I go to draw a triangle that consists of the angle 35 for x and 159.9 for y, it is impossible to draw this triangle because 159.9 plus 35 is already over 180 degrees. So this triangle cannot exist. So therefore, this solution is no good. The only solution that is good is the acute answer. But just remember that you always have to check for the acute answer and also the obtuse answer. The acute answer always works. The obtuse answer sometimes does not work. As you saw in this question here, when we constructed a triangle with angle G being 30, little g 11 and little h 20, we ended up with two answers, 165.4, 114.6, and both of them we were able to draw a triangle. The 114.6 wasn't too big for that other angle. It was still under 180 degrees. So you end up with two triangles in this scenario, but you only end up with one triangle in this scenario. Now, you may end up with something that looks like this, where you're drawing a triangle, we'll call it DEF, and I don't know the situation, but they'll give you, some angle here, they'll give you the side length over here, little d, they'll give you the side length, little e, and you're trying to find big E. And you may end up with something that looks like this. Sine of big E is equal to 1.5. And obviously, using the cast rule, you know that sine is a positive number in quadrant 1 or quadrant 2. Now, when you go to do the sine inverse of this 1.5, you'll see that this actually says error. So if it says error, that means that you cannot construct a triangle with those measurements. So you actually may end up with something like this, where you have sine E equals 1.5, you go to do this, and it's actually impossible to complete the problem, meaning that you cannot construct a triangle with those dimensions. So there are three cases. You can either, and this is why it's called the sine law ambiguous case, because we have to remember when we end up with something like this, where we're looking for the angle, given that sine is positive, we always end up with two answers. One is acute, one is obtuse. The acute answer always makes sense. The obtuse answer sometimes is okay, but sometimes it's too big, like this question here, and therefore there's only one triangle that can be constructed. Sometimes both triangles make sense and both triangles can be constructed. And sometimes you'll end up with something like this as a part of your homework, and it'll say error, and you cannot, that means it's impossible to construct a triangle. If you actually physically tried to construct that triangle of the given dimensions, it would be impossible to do so.